Do any of these acronyms mean something to you? Rocky, 32 gig FC, NVMe, TCP/IP. They should, because I/O matters. Hello, this is Todd Owens. I'm the Field Marketing Manager on the HPE team at Marvell. Marvell is a strategic supplier of technology and solutions to HPE, and today I want to talk to you a little bit about one of the areas that we focus on with HPE, and that's the I/O infrastructure. And what I want to talk about is, why does I/O matter? Well, if we look at what HPE customers are deploying today in their environments, they have a multitude of options of HPE server technology that they can deploy. And there's also HPE storage technology that can be deployed in that data center. And those are all interconnected over some kind of a fabric. Now that fabric can be different technologies. You could have a fiber channel fabric, or you could have an Ethernet fabric. But nonetheless, we have all of our servers connected to our storage. And so why does I/O matter in this case? Usually the bottleneck in the data transfer between the server and storage in days past has always been either in the applications or in the server or in the storage itself. Today, however, we have faster servers. So the new Gen 10 servers and the new generation of servers to follow are faster than ever before. And with HPE's new storage products, things like Primera, we have faster storage as well. So if we've got faster on both ends of the network, that means I/O is going to make a difference. So in each one of these servers, we've got some sort of a I/O adapter. And do you think often about the type of adapter that you're putting in that server? And that's really what I want to focus on today. In addition to faster servers and faster storage, we have customers doing things like virtualization. So they've got all these virtual machines that they need to move around from one physical server to another server. So virtualization becomes a very important application that becomes I/O dependent. And the successful deployment of your virtualization environment is very dependent upon the kind of I/O that you deploy. And what are some of the I/O technologies involved? Well, if we look at I/O technology, the first thing we want to talk about is offloads. What do I mean by offloads? What I mean by offloads is we want to move the work that's normally done with a software driver and maybe some firmware or an application by the CPU, and we want to offload that work into the adapters themselves. So we want the adapters doing the work instead of the CPU and the server. Some of the common offloads you might be familiar with are iSCSI or FCOE for storage communication. There's other offloads like tunneling. Now tunneling, if I can spell correctly here, tunneling is used to move data across disparate data centers. Today, you have a network network limitation of about 1,000 virtual connections that you can make on any given subnet. And in order to move data between data centers, you're talking different subnets, you're talking thousands of virtual machines, and you need some way to encapsulate the data and move it across these networks. Well, tunneling is the way that we do that. And some of the common ways are NVGRE for Windows environments, VXLAN for VMware. Then there's GRE, that's for Linux. And now there's a new one called Geneve, which is generic encapsulation, and it works across all the different operating systems. So those are another example of offloads. One of the most talked about today is an offload called RDMA, Remote Direct Memory Access. And in the storage world, this becomes very critical. Why do I say that? Well, if you think about what's going on in the server and storage environment, we have a technology called NVMe. Now, NVMe is not new, right? But we've got these little NVMe disks that are sitting in the storage or in the servers these days. And we do software-defined storage, things like hyperconverged infrastructure and those kind of things. We want the data to be shared amongst those different storage devices across the clustered servers. We need a very fast network to do that. RDMA is the way to do that. It reduces latency. And so one of the critical parts of RDMA is the fact that there are multiple protocols. So we have RDMA over Converged Ethernet, or RoCE, and we have iWARP. iWARP, some people refer to as Internet Wide Area RDMA Protocol. I think it's just iWARP. But anyway, these two different protocols are kind of like iSCSI and Fibre Channel. They kind of do the same thing, but they're not interchangeable with each other. So, but they both provide very low latency for these kind of connections. And soon, they'll be able to do low latency to our storage arrays. Why? Because we're going to be starting to see NVMe in those storage arrays. You're paying a lot more for those low latency NVMe high performance disks. You want to run them over a low latency network. So that's another offload that you're going to want to have in your adapter. So the story here is I/O does matter. There's a lot of intelligence in I/O adapters that you may not think about. I equate I/O adapters to automobiles. You know, are all cars the same? No. You have to look under the hood a little bit. Same thing with all I/O adapters. You have to look under the hood and understand what technologies and offloads and capabilities are in those adapters. The good news for HPE customers is HPE has a wide variety of I/O technology to offer and can deliver basically everything that the customer needs for their environment to optimize it for running whatever applications they want to do. Thanks for watching. This is Todd Owens. My contact details are below here. Feel free to reach out to me at any time with any questions that you might have relating to I/O technology.